Hey, hello. Let's talk about inverse trigonometric functions. Now, this is just a quick intro to it. We're not going to go too deep into it, and domain and range, we're just going to talk about the basics. So, in class, I gave you this thing to work out. You're to fill out the table. It was a review. Some people remember doing something similar with it. It has changed a little bit. First, I added this column right here. That was the reference angle. That was the distance between the angle and the x-axis. For example, 120 right here. If I were to draw 120, it would be about right there. Beautiful straight lines. So the reference angle, the theta prime, theta with the little tick mark, is the distance to the x-axis. Now it's either this left side or the right side. Since it's closer, the distance is shorter from here to here, that would be my theta prime. So to figure that out, you're either at 180 or you're at 360, depending on which x-axis it's closest to. So since it's closest to 180, to find our reference angle, we had to take 180 minus the 120, and that was where this 60 right here came from. Now, if it was past it, if I was down here in quadrant 3, then it's the angle, your original theta, minus 180. Over here in quadrant 4, it's 360 minus your angle. That's in quadrant 4. Hopefully this is ringing a bell. These are the values. You'll notice a pattern, and that's why we're using this. It's going to help us with solving these equations. So quadrant 1 is the main guy, right? 30, 45, 60, they are their own reference angle. And then once you start changing quadrants, it's the same numbers. They're just reversed, but they're repeated in the same order. So 30, 45, 60, 60, 45, 30, and so on down. Now the importance of those is that when you want to find trig functions of any angle, it all relies on these values right here and the angles that go with them. If an angle has a reference angle of 30, then its sine is going to be either a positive or negative 1/2. Its cosine will be a square root of 3 over 2, positive or negative, and its tangent is square root of 3 over 3. So down here in quadrant 2, under 30, I know it's going to be these values, but the difference is that it's going to change whether it's positive or negative, and that's dependent on the quadrant. Now to remember that, we used all sad turtles cry. Right? So in the first column, first quadrant, everybody's positive. That's this guy right here. Everybody's positive. In the second one, sine is positive. Everybody else is negative, and his buddy, sine and cosecant both. Tangent quadrant 3, cosine gets to be positive in quadrant 4. So in quadrant 2 right here, quadrant 2, sine is positive. Everybody else is negative. So the cosine is actually negative, the tangent is negative. Whatever this value is, it's going to be negative, negative, negative. Speaking of the value, let's see, this row right here for 120, reference angle is 60, so it's going to have the exact same values as the 60 in the original quadrant 1, except for those changes in signs, the positive or negatives. Same thing with the 45, root 2 over 2, root 2 over 2, and 1, but it's negative. So the process keeps repeating. Now when we move into quadrant 3, now it's tangent that gets to be positive, and everybody else is negative. And again, the values repeat. 30 degrees have 1/2 square root of 3 over 2, square root of 3 over 3. Okay, 45s are always square root of 2 over 2, square root of 2 over 2, and 1. And then they're flipped. Right? Last quadrant, only cosine gets to be positive, so these 3 are negative, these 3 are negative, and the values again are all repeated. So 60 degrees is root 3 over 2, 1/2, and root 3, root 2 over 2, 1, and then we flip. Okay, so what this has created here is a table of answers. Like literally, this is what we're going to be doing when we solve equations. For example, if I wanted to know the sine of 30, I can look at my table and say, okay, here's 30, here's the sine. Okay, that's just 1/2, right? That would be a forward way of looking at it. If I just asked you randomly what the cosine of 60 is, you'd look in the table and you'd say, oh, it's 1/2. Okay, tangent of pi over 4. Wait a minute, pi over 4 is radians. So in order to do this, well, two things. You can either next to all of your angles right here, you could go in and you could actually put in their equivalent radians if you wanted just to have it in a nice, easy form. Oops, 6 out of 3. So 30 degrees is pi over 6, pi over 4, pi over 3. So when we say tangent of pi over 4, to convert, you take the angle in radians and multiply it by 180 over pi, so the pi's cancel, and so we get 45. So this is actually the same thing as the tangent of 45 degrees, and you look on your table and it says it's 1. Okay, 7 pi over 6, again, you would multiply by 180 over pi. That's 210 degrees, so sine of 210, looking back, here's sine, there's 210, it is negative 1/2. Right? Cosine of 5 pi over 3, that's actually 300 degrees. 180 over pi, cancels. Okay, cosine of 300, handy dandy table, 300, cosine is negative 1/2. Uh-oh. Oh, I got the wrong signs there. Ah, why didn't anybody stop me? Look, I put the cosine values as negative and they're not. In quadrant 4, cosine is positive, tangent is negative. Shame, shame. I know your name. See, how's it see if you're paying attention? Anyways, so for cosine of 300, it is 1/2. Positive 1/2. Now this one's a little bit different. Tangent of 0. You'll notice in our table here that there wasn't 0. We were all multiples of 30, 45, or 60, and there were no zeros. There's also no 90s, 180s, 270s, or 360s. Those are what are called quadrantal angles. So that's where this new thing comes in today. Now, quadrantal angles, there are no reference angles. There's no reference to them. You just have to understand the relationship between uh, the trig functions and those specific values. So let's look at each one of these individually. I like to look at the graph. Now that you've already learned graphing, I know we hated it, but the basic graph of sine and cosine look like this. Sine's in red. So if my theta is 90, that's the same thing as pi halves, or 1/2 pi. It's this guy right here. What is the sine at that value? Well, go up to the sine curve. Looks like the point right there. Should be in a different color. So this point right here is an x, or a theta of pi halves, and 1. So the sine of pi halves, or 90 degrees, is 1. Then you can also look at the cosine and say, okay, well, the cosine, this blue graph, at pi halves is 0. Okay, let's look at 180. 180 is the same thing as pi. This guy down here is 3 pi over 2. This one is 0 or 2 pi. Okay, let's see. Let's look at sine The sine graph, the red one at pi, is that point right there. So pi 0, that means the sine of 180 is 0. Okay, looking at the cosine. Oops, sorry, I forgot to put this in. Cosine at pi is down here. So that point is pi comma negative 1. So cosine of 180, or pi, is negative 1. Okay, keep going. Going on to 270, or 3 pi over 2. The sine graph, whoopsie. The sine graph right here, looks like that point is 3 pi over 2 comma negative 1. Okay, easy. Seeing a little pattern here. And then the cosine at that point is back here at 0. So 3 pi over 2 and 0. All right, moving on to 0 or 360. Doesn't matter which one you do. I tend to do the 360 to the 2 pi just so we can keep going to the right. So sine graph is right here. That point would be 2 pi, or 360, and 0. Okay, for the cosine, looks like it's this point right here, 2 pi and 1. Okay, there are your sine cosine values for the quadrantal angles. Now here's what it looks like as far as the circle is concerned. We look at, it's called a unit circle, and we didn't cover the unit circle because this table, these two tables, cover all the stuff you need from there. But on what's called a unit circle, we're defining the radius to be 1. So this point right here on the circle, that gives me an x and a y. And if you remember, the sine was y over r. We reviewed this at the beginning, but we'll talk about it real quick again. But I have scaled this circle down to where r will always be 1. So it's just going to be the y value. So sine of 0 or 360 looks like it is 0. Bam. The cosine is x over r. R is just 1 though, so it would be the x value. So on the coordinate system, right, quadrants 1, 2, 3, and 4, we've got 0, 90, 180, 270. For these values, you just picture these points right here. Points that are 1 unit away from the origin on the actual x-axis. And then if you look at the coordinates, the x is always the cosine, y is always the sine. All right, what about tangent though? Tangent is sine divided by cosine. All right, so here that would be 1 divided by 0. Uh-oh, can't do that, so we call that undefined. 180 is 0 over 1. 0 divided by anything is 0. 270, again, 0's in the denominator, so it's undefined. And then 0 and 360 is 0 over 1, or 0. So quadrantal angles, those are going to be the values that come up when you're given 90, 180, 270, or 0, or their reference angle counterparts.